sorry about that. My lights are motion censored and I've been sitting here too long that they turned off and then I couldn't pick up on my video where I'd left off. So this is part 3, talking about conversions. We were in the middle of a problem, so I'm just going to pick up from that problem. We were looking at this example here, 7.24 times 10 to the 24th, atoms of carbon into moles. So I'm starting with my 7.24 times 10 to the 24th atoms. Atoms comes on the bottom, moles goes on top in order for atoms to cancel and get left with moles. Then we saw Avogadro's number, 1 mole is equal to 6.02 times 10 to the 23rd atoms. So I stick in 1 mole on the top and 6.02 times 10 to the 23rd atoms on the bottom. And we're about to plug this into our calculator. So you've got 2 options. Either use the E button, or if you don't know how to do that, then put all of your scientific notation into parentheses. Even if you don't know how to use the E button, it never hurts to use parentheses around your things that you're sticking in. So I'm going to try to show this so you can see everything. Maybe that will be my best bet. All right, I'm going to start off with this number into the calculator first. So 7.24. Again, your EE button, at least on my calculator, is right above this comma. It's that capital EE. And in order to get there, I have to hit the blue second button. So second, EE. If you have a Casio, you might have this EXP button or the times 10 to the X button. That will do the same thing. That takes the place of times 10. So then all I have to do is plug in my exponent, which in this case is 24. And then divided by, well, I could multiply by 1, but anything times 1 is itself. So then I just care about this part that's on the bottom. So I divide by my 6.02 E button, 23, equals, I get 12.02657. I need to round that to 3 digits, so 12.0, and I need to include my unit, which is moles. Now, if we want to check that with parentheses, just to make sure that you're plugging it in correctly, parentheses 7.24. A lot of students just like to do times 10 and then use this little caret to give the exponent. That's fine as long as you put it in parentheses. So then we'd have to the 24 and parentheses divided by, then let's plug in this next part in parentheses, especially in parentheses. So my 6.02 times 10, this little caret off to the side, 23rd, end parenthesis equals, we get the exact same answer as we had before. Whew, good. Now if we didn't have the parentheses, then you would have problems. If we took out the parentheses, you get a completely different number, e to the 47th power. That is not correct. It's the exact same thing that we plugged in, but it's without the parentheses. You have to either use the EXP button, the EE button, the times 10 to the X button, or you have to put it in parentheses. Now, let's put all of these conversions together. So we've got this little mole map from our mass to moles, use molar mass. From our moles to molecules or atoms or particles or formula units, we use Avogadro's number. Let's put all of those steps together. For this last problem, how many atoms of copper are in a 3.76 gram sample? This is what I'm starting with, my 3.76 gram sample of copper, which is Cu. I need to get into atoms. How many atoms do I have? So I'm going to have to set up my fence posts so that my grams cancel. But I can only go from grams into moles. I cannot, in one step, go all the way from mass into my atoms, I have to go through moles first. So here, my grams, I'm going to put grams on the bottom so that they cancel, and I can only convert grams into moles. In order to do that, I have to use my molar mass. So I'm going to look on the periodic table, find copper. Copper here, it says 63.546. So copper is 63.546 grams per mole. That means that it's 63.546 grams is equal to 1 mole. My 1 goes with my mole, so I put that on the top, and my 63.546 grams goes on the bottom with my gram unit. Perfect. Grams cancel. I'm left with moles of copper. Now, I'm not to where I needed to be. I needed to be all the way in atoms. So I have to set up another fence post. Because I don't want to stay in moles, I need to be in atoms. So I have to cancel moles. Moles comes here on the bottom diagonally so that they cancel diagonally. And then I can convert moles into atoms. So I'm going to put my atoms on the top. Now, in order to go from my moles into my atoms, I have to use Avogadro's number, which is 1 mole is equal to 6.02 times 10 to the 23rd. So that means 1 mole is 6.02 times 10 to the 23rd of my atom. That's how I set it up. When I'm plugging it into my calculator, I'm going to start over here on the left side, plug that number in first, multiply by 1 because it's on the top. Well, anything by 1 is itself. This goes down, so I'm going to divide by 63.546. Then it jumps back up to the top, so I'm going to times by 6.02 to the 23rd. And then I could include this 1 and divide by 1, but anything divided by 1 is going to be itself. So let's plug that in to my calculator. Got my 3.76. I'm going to start there first. Then divided by, 3.76 divided by my molar mass down here, my 63.546. Then it jumps back up here to the top. So I'm going to plug this into my calculator using the E button. I'm going to try to show everything. 6 times 6.02. I'm going to use that E button to the 23rd equals, I get an answer of 3.56 with a whole bunch of numbers. Notice that it gives us an E to the 22nd at the very end. I have to include that in my answer, otherwise my answer is incorrect. If I just put the 3.56, that is incorrect. I have to include the E, which means times 10, and then the 22, which is my 22nd power. That is my actual answer. Include my unit. Well, everything cancels except atoms, which is what I was trying to find. So this is 3.56 times 10 to the 22nd atoms of copper.